Hello students, this is a review of some problems from end of chapter 4 from your textbook. Okay, so let us see. uh, let me choose a pen. Okay, so here what we want to do is that this is question number 1, part A, end of chapter. A price consumption curve and a demand curve. They want to know the difference between these two. Okay, what is the number 1, right? What is the explain the difference between each of the following terms. So what is the difference between a price consumption curve and a demand curve? So let us take a look at price. This is what here in this slide you can see that there is what we can see. You can see that this is the price consumption curve, right? So this price consumption curve is showing us the combination, the consumer's equilibrium for at a different level of this is an income consumption curve. Let us take a look at a price consumption curve here. Price consumption curve, this one is telling us in this slide that this price consumption curve is the locus of this point, right? Locus combination of all these points that show us the what the consumer will consume at given different price, right? So here we are measuring clothing on the vertical axis, food on the horizontal axis. Okay, and this is the initial budget line, right? And that at that budget line we are consuming clothing, right? C, 6 units of clothing when the equilibrium is at point A. This is the first equilibrium, right? Remember the tangent between the indifference curve and the indifference curve, this one U1, and the budget line given by this, right? Okay, so that is equilibrium. And then what happens is that when price changes, the consumer price of food decreases, so he can then buy more, but price of clothing doesn't change. So this intercept does not change, but this intercept will change, right? Because now price of food has gone down, they can buy more. As we have explained to you, the budget line will swing. Sorry, it will not shift, it will swing, it will rotate. And then the new equilibrium with the new budget line here at the new equilibrium as point B. See, this is also another equilibrium, but this is at that equilibrium point the consumer is consuming 4 units of clothing at that price. Okay, and then here at the first equilibrium U1, the consumer was consuming 4 units of food. Now he's consuming 12 units of food. See that budget line rotate, his equilibrium moves from A to B, and now what he's consuming at the equilibrium, he's consuming 4 units, 12 from 4. Now in the new equilibrium at B, corresponding to B, consuming 12 units. Now what will happen if the budget line again rotate? If price of food fall again, we know that budget line will rotate further and it will swing out. And here we have point D. At this point D, what happens? At that point D, we have U3 indifference curve and D. You see that? So that is the tangent point. At that tangent point, what happens? That new equilibrium. This is the equilibrium when price correspond to the new budget line. The consumer is consuming 20 units, right? So from 12 now his consumption is increasing to 20. See? So that is price consumption curve, PCC, price consumption curve. And now let us take a look at the demand curve. This is demand curve for food, right? We have price, quantity of food demanded on the horizontal axis, price on the vertical axis, right? And now what happens? Now we see that this demand curve will show us the relationship between price of food and quantity demanded of food at that price. So when price of food is $2, this is the amount, the amount of food they consume is 4. So here E correspond to that equilibrium A. See that price ratio At that price ratio, price of food was 2, and the consumer was consuming at equilibrium 4 units of food. Then the next one, when the price of food decreases from $2 to $1, right? $2 to $1. This is the what? This is the corresponding uh, point. So this is the equilibrium B, and corresponding to that equilibrium B, we have this point on the demand curve. Here, price of food is $1, and the consumer is consuming 12 units, right? Okay. Then now the next one is what? Price goes to 50 cents. And then this is the budget line. So remember, budget line again shift out when price increases, decreases, price of food decreases further from $1 per unit to 50 cents per unit. And at that new equilibrium D, they will consume what? They will consume at point H, right? And they and 50 cents they will demand will be 20. See that? So that one, panel A and panel B. Panel A is here on top, this one, and panel B is this one. So the baskets that maximize utility for various food prices of food. Point A is $2 right here. So let me change color. Point A is this one, right? We discussed. And point B is which one? Is $1, this one. And point D is what? This one. Here price of food is 50 cents. Trace out the price consumption curve. See, price consumption curve will tell us what is the different combinations of food and clothing that he will buy as price of food is changing from one equilibrium to another equilibrium. And in part B, this one, the demand curve which relates the price of food to the quantity demanded of food. Points E, G, and H correspond to point A, B, and D respectively, as we have explained. See, so demand curve will show us the relationship between price and quantity demanded at each of those prices, and price consumption curve, that PCC, will show us what is the equilibrium of the consumer, what is this one, equilibrium of the consumer as price is changing, right? Okay, now let us go and take a look at the next one, the difference between an individual demand curve and market demand curve. See, market demand curve. So an individual demand curve plots the quantity demanded by one person at various prices. So here we have what? Price, and here we have individual quantity demanded Q, right? So the demand curve D1 will show us what is the price at different quantity demanded. This one, right? And on the other hand, this is low uppercase Q, and this is P. We have this one. This is the aggregate demand curve. See, that Q uppercase, that is the aggregate demand, means that it is sum of all the individual quantity demanded, right? So for every price here, we are summing up this individual quantity demanded by many individuals. This is just one individual. There will be many demand curve like that, individual demand curve, and for every price we will sum the individual demand, all the individual demand, and that aggregate will be represented here in the market demand curve, right? Okay, so here in this slide we have the concept market demand curve, right? So how do we get that? Market demand curve is relating the quantity of a good that all consumers in the market will buy, right, to its price. So all consumers, demand by all consumers, purchase by all consumers to the price of the product. So let this in here they give us from individual to market demand. How we explain that in this slide, right? These slides are on canvas, you know that. When price is $1, individual will want to buy 6 units. Individual 10 will buy, or B will want to buy what? 10 units. See, in an individual C will want to buy 16 units. Now if we add all of them together, so this will be what? Aggregate demand, market demand. Market, let us simplify. Let us say that we have only A, B, C in the market, no other individuals. Like just a simplification. So when price is 1, combined demand, aggregate demand is 32. See, and then likewise when price is $2, let us Individual A wants 4 units, individual B wants 8 units, individual C wants 13 units. So it is what? 25. See that? 25. So add all of, so and similar for all other. And then when we plot this price on the vertical axis and plot this in the horizontal axis, right? So this is what? Uppercase Q, aggregate demand, and this is price. That demand curve is then what? The DM, the market demand curve. We call this the process of horizontal summation, because we are summing all these individual demand horizontally for every price. For every price, we will sum up the demand, or it's what? The row. Sum of all of this row, right, is this. Sum of all of this row is what? This, each corresponding to their the price. Then let us discuss an angle curve, right? An angle curve and a demand curve. What will be the difference between them? So let us take a look at this. An angle curve shows the quantity of one good that will be purchased by a consumer at different income levels. See? So when income of the person is increasing or decreasing at each of those levels, how much of the consumer will buy for that commodity. That will be his angle curve, right? Now the quantity of good is plotted on the horizontal axis, and the consumer's income is plotted on the vertical axis. We will soon show you from the slides, right? This is an angle curve. On the other hand, a demand curve is like an angle curve, except that it shows the quantity purchased at different prices instead of different income levels. So see, so what they are saying here is, if we go back to the slides and look for the Engels curve, right? Let us take a look if we can here. Look at that. This is the Engels curve. So Engels curve, they are telling us curve relating the quantity of good consumed to income. We are measuring quantity of good consumed at the equilibrium here, excuse me, and this is the income level. When income is 10, right, they are consuming 4. So this is the point. When income is 20, they are consuming what? They are consuming here 10 at this point. When income is 30, they are consuming what? Consuming 16. See that? So this is showing this is the Engels curve. Now here, just to relate, this is panel A. Food is normal good. The angle curve is upward sloping. See, it's an upslope line. As you move to the left, the curve is going up. Panel A. What about panel B? However, hamburger is a normal good for income less than 20. So for income less than 20, it is a normal good, but per month, and an inferior good for income greater than 20 per month. So see, this one, income is 20. If income increases, this is going up so line, right? This one. So it is a normal good for that income level. But when income level further increase further, right? Income is more than 20 from above that level, right? So look at that. The person is what? The Engels curve bending backward. So the person now will consume less and less, right? So this is an inferior good. For an inferior good, the definition is what? For an inferior good, when his income increases, he will buy less. So inferior goods are like what? Cheaper brand goods like ramen noodles, like used car, used tire, right? Like cabbage in vegetable, cabbage is inferior good compared to asparagus, right? Or what? Gas grill compared to charcoal grill is inferior good compared to gas grill. Well, when people have low income, they will buy and use charcoal grill. But then it's messy to clean and cook in charcoal grill. So when their income increases, right, beyond the threshold level, they will buy less gas grill and more they will buy less charcoal grill and more gas grill, because they can afford to. Gas grills more expensive, right? So that is why. So see, so now in part D, they are asking us what is the difference between an income effect of a price change and a substitution effect of a price change. See, both the substitution effect and income effect occur because of a change in the price of a good. Now, the substitution effect is the change in the quantity demanded of the good due to the price change, holding consumers' utility constant. See that? So we will keep the level of utility of the consumer constant, so he will have the same utility consume before and after the price change. But then what will happen, when the price of a good changes, its relative price compared to other goods will change. Then consumers will switch from the more expensive to the less expensive good. For example, in the substitution effect, if the price of some good increases, what happens? It becomes more expensive compared to its substitute. So some consumers will then switch to other goods. And that is why demand will change when relative price changes, right? Price of one good changes relative to other goods. That is the substitution effect. On the other hand, income effect is what? Is the change in the quantity demanded of good due to a change in the purchasing power brought about by the change in the goods price. See? So when price of some good, for example, decreases, the same money will now buy more. As a result, purchasing power of money will go up. We will say that real income of the person has gone up, although nominal income did not change. Nominal income, the number of dollars that he's earning did not change, but his real income, purchasing power of money will increase, and then he will buy more if it is a normal good, right? So that change is called what? That change in the behavior of the consumer we call is income effect. Okay, all right. Now let us take a look at this one, number 2. Suppose an individual allocates his/her entire budget between two goods, food and clothing. Can both goods be inferior? So it can be a situation where if income increases, the person will buy less of the more goods. No, it cannot be, right? That is the answer. The goods cannot both be inferior. One can be inferior, but then the other has to be what? Has to be a normal good. At least one must be a normal good, such that if income increases, consumer will buy more of that good. See? Inferior goods mean that if income increases, a person will buy less of that good. So, and both cannot be inferior goods, because then one must be such one normal good, because when income increases, he will buy more of that good always. And for the other good beyond a threshold level, if the other good is inferior good, as income increases, he will buy less, right? So the money that he is now not investing on that inferior good will now be spent on normal good. For any level of income, he will buy more. Here is why: if an individual consumes only food and clothing, then any increase in income must be spent on either food or clothing, right? Or both. Recall, we assume there are no savings, and more of any good is preferred to less. So this was an assumption for indifference car, right? Even if the good is an inferior good. See? So if good is an inferior good, if food is an inferior good, then as income increases, consumption of food falls, which is the definition of inferior goods, right? With constant prices, the extra income not spent on food must then be spent on what? On clothing. That is the thing. Therefore, as income increases, more is spent on clothing. Clothing is a normal good, and the other good, food, is what? Is an inferior good, because they are buying less and less food, even if income is growing, even though income is going up. So that is why. Now the next question is what? Explain whether the following statements are true or false. So let us examine. Marginal rate of substitution diminishes as individual moves downward along the demand curve. Is this true or false? This one, right? True. Why is it true? The consumer maximizes his utility by choosing the bundle on his budget line where the price ratio is equal to MRS, right? Remember the equilibrium condition and the tangent between the indifference curve and budget line, right? Slope of the budget line is the price ratio, slope of the indifference curve is the MRS. At that point, MRS equal to the price ratio, right? Okay. Now with that knowledge, for goods 1 and 2, P1 and P2 is MRS, right? So if we have such words, a graph like that, for example, we are measuring units of good one that they consume in this axis, units of good two that they consume in what? In that axis, right? As the price of good one falls, the consumer moves downward along the demand curve for good one, and the price ratio P1 P2 becomes smaller. See, is that okay? So this is the consumer's equilibrium. Now if we go to the demand curve, right? MRS must be smaller, become smaller, and thus MRS diminishes as individuals move downward along the demand curve. So the price ratio is P1 P2. Now if price of good one falls, if so, see the slope is P1 and P2. Now what happens if price of P1 falls? The denominator in the slope is decreasing, right? This one is equal to MRS. We already said that at the equilibrium. And if this is decreasing, that means MRS, it implies that MRS also is decreasing, right? So that is what. Therefore, MRS must also be smaller, and thus MRS diminishes as individual moves down along the demand curve. If this is his consumer equilibrium graph, if you look at his demand curve, so you can see Q and price, right? This is the demand curve. So we are saying that as we move, as we are so uh, so consumer move down along the demand curve for good one. This is demand curve for good one, right? The consumer moves down in this direction, right? And as a result, what happened? Downward along the demand curve for good one, and the price ratio P1 P2 becomes what? Becomes smaller. Therefore, MRS must also become smaller, and thus as we are consuming more of good one, we can say that because of this decrease in the price, decrease in P1, right? As we consume, remember law of demand, price and quantity inversely related. When we consume more Q, price P of P consume more of Q1, price of P1 is decreasing, and here from here we know price of P1 is the numerator, slope is decreasing. MRS, since the slope is equal to MRS will also decrease. So we can find out, we can easily now argue that, hey, as we move down the demand curve, what happens? That MRS is going to decrease. Why? This will be the result of the decrease in P1, which is the numerator. Yeah, numerator in the MRS formula. Okay. Now let us see. Now let us take a look at this one. Problem number B. The level of utility increases as an individual moves downward along the demand curve. So they are saying that if we are moving downward to the demand curve, level of utility decreases. As the price of a good falls, the budget line pivots outward, and the consumer is able to move to higher indifference curve. That is why you see that. Remember when if we go to that budget line graph, so this is when price is higher, we are on the low indifference curve. So when price of suppose food, we are measuring food here, origin, and this is what? Cloth, right? And then we will rotate. This one will rotate. When price of food decreases, we know that what? We know that that slope has decreased. Look at that, right? So look, and as a result, what happens? We move to a new indifference equilibrium, tangent to a new indifference curve, U1 and U2, and so on. Now look, U2 is higher than U1. So that is what they are saying. When the price of good falls, what happens? This budget line will rotate and move outward, and then it will be tangent to higher indifference curve, U2. Before it was U1. And consumer is able to move to a higher indifference curve. So utility will increase, right? Now next one, is Engel curve always slope upward? Is that Engel's curve always slope upward, true or false? This is what? This is false. Why so? The answer is given here. Look at that, this one. This is the Engel's curve. It is only for normal goods is what? We have this upward Engel's curve, only for normal goods. But here, what happens? Here, for hamburger is not a normal good. For when price is between 10 to when income between 10 to 20, he will consume more. When income increases, he will consume more. But when income increases from 30 to 20, when income increases from 30 to 20, then what? He will then cut down on his consumption, right? So look at of hamburger. Look at that. It is going backward. As income increases, he will consume less. Income increases, he will consume less. Okay. All right. So that one. So this is why it is false. Let us take a look at this. What is going on here? Number 4, tickets to a rock concert sell for $10, but at that price the demand is substantially greater than the available number of tickets, right? Okay, in the value, if the value of marginal benefit of an additional ticket greater than, less than, or equal to 10, how might you determine the value? That is the question. See, so let us take a look at this diagram below. At when price is $10, right? Consumers want to purchase queue tickets. Price is $10, they want to purchase queue tickets, right? But only Q star are available. Look at that supply curve. It is vertical. It means that when price changes, supply doesn't change. It remains fixed at Q star. Consumers would be willing to bid up the price to P star, because at that price 10, this is demand and this is supply. So there is a shortage here, right? Shortage here. So consumers will then bid against one another and put pressure on price to increase until P star, where P star, right? When price is bid up, price starts to increase. Look, the size of that shortage is decreasing until here we have the new equilibrium at that point of intersection. Again, demand, quantity demanded equal to quantity supplied, right? And this is quantity demanded higher than quantity supplied at that $10, right? Since the utility maximizing consumers are willing to pay more than 10, the marginal increase in satisfaction, that is the value of benefit of an additional ticket, is greater than 10. One way to determine the value of an additional ticket would be to auction it off, right? Another possibility is to allow scalping. Scalping means that they will allow people to buy, and then some of those people will sell it in the illegal market to other people, right? So often you will see that just before the game starts there is scalping, right? Many people, they want to watch, they have money but they don't have ticket, so they will pay a little bit more or sometimes much more to buy a ticket and go and watch, right? Since consumers are willing to pay an amount equal to the marginal benefit they derive from purchasing an additional ticket, the scalper's price equals that value. See that? So marginal benefit at that, here marginal benefit equal to marginal cost. Now what about this one? Problem number 5. Which of the following combination of goods are complements and which are substitutes? Can they be either in different circumstances, right? So let us see. A mathematics class and an economics class, are these complements or substitutes? If the math class and economic class do not conflict in scheduling, then the classes should be either complements or substitutes. See, Math is important for in understanding economics, and economics can motivate mathematics, right? So that is why you see what these two are interdependent, and a lot of math in economics. So the classes would be complements. See, so you need one, and then you need the other one also. You can have both together. So though in that sense, complement. Remember, complements is like left shoe and right shoe. You need one and the left shoe, and then you also need another one, right shoe, and make a pair of shoes, right? Like DVD players and DVDs. If you have more DVD players, then you need more DVDs to play in them. So those are consumed together, complements, right? If the classes conflict or students has room for only one in his schedule, then they are substitutes. They can be used one instead of the other. See, substitute. So it depends on the situation. Now about B, tennis ball and tennis racket. Are these complements or substitutes? Tennis ball and tennis rackets are both needed to play tennis. So they are complement. They are often used together and often purchased together, right? You buy a tennis ball, you buy a tennis racket, then you will buy what? Buy tennis balls to play with, right? Steak and lobster. Food can both complement and substitute for each other. Steak and lobster can be substituted as when they are listed as separate items on a menu. So you can either have steak or have lobster, right? However, they can also function as complements because they are often served together, right? In that case, depending on the situation, if they are served together, they are like complements. You eat one and then you also want to eat another. A plane trip to train and a train trip to same destination. Are these complements or substitutes? Two modes of transportation between same 2 points are substitutes for one another, right? So you can either go by plane or by train, right? Okay, and to the same destination, right? It's not that part of it you go by plane and other part you have to go by train. If that is the case, if you then plane trip going to one destination and the remaining of the way another destination in train trip, then it might be complement. But here in this, because they are going to the same destination, they are what competing. So either plane trip or train trip, so they made substitutes. Bacon and eggs. Bacon and eggs are often eaten together and are complementary goods in this case. However, in relation to something else such as pancakes, bacon and eggs can function as substitutes, right? Either you eat pancake or you eat bacon and eggs, right? Either you when you are eating pancake, you can eat pancake with bacon or eat pancake with eggs. Then bacon and eggs, they become substitutes, right? What combination? You have pancake, and which of these other, bacon or egg, do you want? So the bacon and egg competing with one another. There's then substitutes. Again, this depends on the situation, right? Now let us see in part 6 they are asking us what? Suppose that a consumer spend a fixed amount of income per month on the following pairs of goods, right? Tortilla chips and salsa, tortilla chips and potato chips, movie tickets and gourmet coffee, travels by bus and travel by subway. If the price of one of the goods increases, explain the effect of the quantity demanded of each of the goods. In each pair, which are likely to be complement and which are likely to be complements and which are likely to be substitutes. Let us discuss. Pair A, this one, tortilla chips and salsa. If price of tortilla chips increases, consumer will demand fewer tortilla chips. Since tortilla chips and salsa are complements, they are purchased together. And now because he will buy less tortilla chips, then he will buy, his demand for salsa will also drop. See that? The demand curve will shift to the left and the consumer will demand less salsa, right? So these are like any other complements. If like DVD player and DVD, right? Like tennis racket and tennis ball. If price of tennis racket increases, people will buy less tennis rackets. Then they will also buy less tennis balls, right? They don't need it because they are not playing. It's becoming expensive. Okay. So the same situation here. What about B? B is what? If the price of tortilla chips, so we have tortilla chips and potato chips. Tortilla chips increase, the consumer will demand fewer tortilla chips. Since tortilla chips and potato chips are substitute, the demand for potato chips will increase. See, because here we are saying that price of tortilla chips increases, and but price of potato chips do not increase. So potato chips become more expensive compared to, sorry, tortilla chips become more expensive compared to potato chips. So now people switch. They want to save some money. They will switch from tortilla chips to potato chips. Maybe next week when price of tortilla chips come down, they will have come back and buy tortilla chips again. What about C? A movie ticket and gourmet coffee. The consumer will demand fewer movie tickets if price of tickets increases. You might think that demand for movies and gourmet coffee would be independent of each other. However, right, independent, so it doesn't matter. They consume movie tickets separately from gourmet ticket. That is what this independent means. But however, because consumer expends a fixed amount on the two, the demand for coffee will depend on whether the consumer spends more or less on of her fixed budget on the movie after the price increases. See that? If consumers demand elasticity for movie ticket is elastic, right, she will spend less on movies, and therefore more on her fixed income of her fixed income will be available to spend on coffee. See that this is a budget issue. So he's spending a fixed amount. So if he's not buying movie ticket, then he will probably spend that extra amount on coffee, right? Now the goods are substitute in this situation. If her demand for movie is inelastic, right? Demand for movie is inelastic, means elasticity less than 1, and here elastic means it is what? More than 1. If it is inelastic, then what will happen? She will spend more on movies after the price increase, and therefore less on coffee. In this case, she will buy less of both goods in response to the price increase or for movies. So when it is elastic, that means that even if price increases, right, consumer will buy less, but that will be smaller than the what? The decrease in than the increase in price. So you know that this is, excuse me, price elasticity of demand. So this is the ratio of percentage change in quantity equal to what? Percentage change in quantity divided by percentage change in price, right? So this is a delta, meaning change. So it means what? Here the ratio is less than 1 means what? Even if price increase changes a lot, quantity, the numerator percentage change in quantity is not so high. In this case, she will buy less of both goods in response to the price increase for movies. So the goods are what? Complements, right? Finally, if the demand for movies is unit elastic, right? So now we are saying that this is equal to 1. So this percentage change in price and percentage change in quantity, they are equal, and this is equal to 1. She will spend the same amount on movies, and therefore will not change her spending on coffee. In this case, the goods are unrelated, and the demand curve for coffee is what? Is unchanged. See, so here this one means that if price increases $1, this denominator price increases $1, quantity demanded will decrease by 1. If price increases 1%, quantity demanded will decrease by 1%. A change here is will be if price increases, quantity demanded will decrease, vice versa, law of demand, right? So that is what they are telling us here. And as a result, what happens? If it is unit elastic, she will spend the same amount on movies, and therefore, right? So if price increases 1%, demand will decrease 1%. So she's spending the same amount. In this case, the goods are unrelated, and the demand curve for coffee is unchanged. It does not depend on demand for anything else. So here we can also explain one thing is that see, for here, for when something has elastic demand, that means what? That means when price increases, demand price increases, total revenue, total expenditure on the item, will decrease. So when we have this kind of elasticity, price and total expenditure will change in opposite ways. If price increases, total expenditure will decrease, vice versa. And depending on that, whether total expenditure is increasing, decreasing on that item, then how much money left over to buy the other item, we can find the demand, change in the consumption of other goods, right? Whether then coffee and movie ticket complement or substitutes. On the other hand, if we have this situation, right, if price elasticity of demand is inelastic, then price versus total expenditure, this will be what? Directly related. If price increases, total expenditure will increase, and price decreases, total expenditure will decrease, vice versa. See that? So that will be another thing. Okay, we can use these arguments about what happens to total expenditure also to find to in these answers. Now what about D? If the price of bus travel increases, let us see. Then part D, they are asking us the two goods, bus travel and travel by subway. Again, if the price of bus travel increases, the amount of bus travel demanded will fall and the demand for subway rides will increase, because travel by bus and subway are typically substitutes. And then the demand curve for subway rides will shift to the right. If subway ride demand will increase, more people will switch to subways and they will not ride by a bus. Why? Because bus became more expensive. So let us take a look at these mathematical exercises in your textbook, right? End of chapter. So let us say that they are giving us this information that an individual sets aside a certain amount of his income per capita to spend on his own on his two hobbies, right? Collecting wine and collecting books. Given the information below, illustrate both the price consumption curve associated with changes in the price of wine and the demand curve for wine, right? Okay. Now price of wine, price of book, quantity wine, quantity of book, and the budget is 150. See, when price is $10 and price of wine $10, price of book $10, quantity of wine is 7 and quantity of book is 8. See that? Okay. And then what happens? So, and then when price of wine goes to $12, increases, price of book does not change, right? Quantity of wine will now decrease, wine become more expensive, see that? So they buy less of it and they are buying more of books, right? And then again price increases from 12 to 15, then again demand for wine decreases 5 to 4. This time demand for book does not increase. Then again when price of wine increases from 15 to 20, quantity of wine again fall from 4 to 2, and the quantity demanded for book increases from 9 to 11. So let us see. Given the illustrate both price consumption curve associated with a change in the price of wine and demand curve for wine. So see, price consumption curve, remember that tells us PPC, PCC, price consumption curve, right? This tells us this is wine and this is the book price consumption curve, and when for different price what are they consuming. See here, this bundle is 11 books and 2 wine. We are measuring books on the vertical axis, wine on the horizontal axis. See 11 books and 2 wine. Then the next combination is 4 and 9. So this is 4 and this is 9, right? And this is what? This is 5 and this is what? 9. See that? Okay, and this is 7 and this is what? 8. 7, wine is 7 and quantity of book is 8. So this is the price consumption curve. These are the combinations that he will buy at the equilibrium given these prices. This is changing, these combinations are changing because price of wine is decreasing, is increasing step by step. Now what about the demand curve for wine? See, for demand curve for wine, what happens? For demand curve for wine, what happens? This is the price of wine and this is the demand for wine. 7, when price is $10, demand is 7. Price is $12, demand is 5. And then price is $20, demand is 2. So 20 and this is 2. And this is 15 and this is what? 15, this is what? 4. See that here? 4. And this is 20 and this is what? 2. Price of wine is 20 and then it will be what? Demand will be, they don't show it 20 and 2. See, 20 and 2, 4 income is 15 and then what? 12 for income level 12 here, right? Somewhere here it is what? It is 5, right? And then income level 10, it is what? 7. See, so that is what the demand curve will tell us. So from this information we can find both. Now an individual consumer's two goods, clothing and food, given the information below, illustrate both the income consumption curve and the Engel curve for clothing and food. So what is going on here? There is what? This is income. Look, income is changing, right? And when income changes, right, what happened to demand for clothing and what happened to demand for food? So that is what they are showing us here. But before that, let us discuss income consumption curve. Income consumption curve will tell us how much of the two goods, food and clothing, they will consume. The consumer will consume as income is changing for different levels of income. So see, when income is 100, they will consume what? 6 units of clothing and 20 units of food. They tell us. So this is what? Food is what? Food 20 units and this is 6 units. See that? This one. And then this is what? And then when they're consuming 8 units of 8 units of what? 8 units of clothing, 35 units of food. 35 units, right? 35 and 8 units, right? This one here. Then this is 45 and 10. Then this is what? 45 and what? 45 and 10. And then this will be quantity of food is 50, and this one is what? Quantity of clothing is 15. See that? So that income, that is the income consumption curve, right? Okay. So we have food here and we have clothing here. Now what about the next one? Next one is the Engels curve, right? Food and income. So here we are, this is 100, this is at that level of income, this is his demand for food. At that level of income, this is what? This is 35, their demand for food. See? So this for food. Here similar for clothing. Their demand for clothing is 6 when income is 100. When income is 150, their demand for clothing is 8. See? So this one is what? 150 demand for clothing is 8. 100 demand for clothing is 6. So we are plotting those information in here. income always for Engels curve, income always will be on the vertical axis, both here and here. For food Engels curve, we measure food on the horizontal. For clothing Engels curve, we measure clothing, demand for clothing on the horizontal, right? So let us see what are they discussing here. Number 4. Number 4, they are telling us that orange juice and apple juice are known to be perfect substitutes. See, draw the appropriate price consumption curve for a variable price of orange juice and income consumption curve. We have to measure price consumption curve, income consumption curve. So see, we know that indifference curve for perfect substitutes are what? Straight lines like the line EF. See that in the price consumption curve diagram below. This is, we are measuring quantity of orange juice vertical axis, quantity of apple juice on the vertical axis, quantity of orange juice on the horizontal axis, right? Like the line EF in the price consumption curve diagram below. In this case, the consumer always purchases the cheaper of the two goods. Assuming a one for one trade-off, if the price of orange juice is less than the price of apple juice, the consumer will purchase only orange juice, and the price consumption curve will lie along the orange juice axis for this graph. See that? So this is, as long as price of orange equal to price of apple, we will be somewhere here because the consumer is indifferent. It will depend on his indifference curve, right? But then if price of apple higher than price of price of orange higher than price of apple, orange more expensive, then he will only consume apples. On the other hand, if price of apple higher than price of orange, he will only consume what? Orange. See, this perfect substitute, so he does not have any problem. This is what they're saying. If price of apple is cheaper, here this part, consumers will purchase only apple, right? And the price consumption curve will be on the apple juice axis, right? Point E. So if the two goods have the same price, the consumer will be indifferent between the two here at this point, right? And the price in consumption curve will coincide with the indifference curve between E and F. Assuming price of orange is less than the price of the apple here, the consumer will maximize her utility by consuming only orange. As income varies, only the amount of orange juice varies. Thus, the income consumption curve will be along the orange juice axis, as the figure below. If apple juice were cheaper, the income consumption curve would lie on the apple juice axis. So look at that here. Here, what are they saying? This is apple juice, orange juice, and income consumption curve will be here. If in this case, what happens? Price of orange juice is cheaper than price of apple juice. So we know that this consumer will always consume orange, because the orange and apple to him is perfect substitutes. So this budget line, dash line, is telling us that in this case, if we are measuring price of orange juice there, slope of the budget line will be what? Slope of the budget line will be price of orange divided by price of apples, right? And then this one is telling us what? Price of orange is equal to price of apples. And then they are telling us that in this case they will this is less than 1. Look at that, this slope, dash line, budget line has slope smaller than that indifference curve, right? Indifference curve. So his indifference curve is straight line because these are perfect substitutes. As a result, we have solution over here at that corner. He will spend all his money on orange juice. and if his income is higher, he will then go to this level of oranges, see, and on another budget line. So his income consumption curve, as his income increases, this will be his income consumption curve, as long as this is true. Now what about this one? This is left shoe and right shoe are perfect complements. Draw the appropriate price consumption and income consumption curve. For perfect complements, we have what? You know that the indifference curve will be L-shaped, because look at that L1, right? L1. Here, the only when he's buying these goods in the proportion shown by this, then his utility will increase. Otherwise not. Let me explain. L1 here. This is his utility, but if he is buying left shoes alone, his utility is not increasing. He's still on U1 indifference curve. If he is buying right shoes alone, again his utility will not increase. He's only buying right shoes, right? Okay. Now here also, here utility is increasing in this direction. If he buys left shoe alone, his utility is not increasing. If he buys right shoes alone, again he's on the same indifference curve, U2. His utility will not increase. Only when he's buying in this proportion will his utility increase, and his indifference curve will move what? Will shift up like this, right? Always L shape. So in the case of perfect, so let us see. For perfect complements such as right shoes and left shoes, the indifference curve are L-shaped. The point of utility maximization occurs when the budget constraints L1 and L2 touch the kink of the U1 and U2. See the following figure. See, so this is the budget line, and it is touching U1 at that point. So that is one equilibrium. On the other hand, alternately, this can be another budget line, that dash line L2, and then the L2 is tangent to U2 only and at that kink. See, only at that kink. This is a unique situation. As a result, what happened? That dark line, this is the price consumption curve. As budget line shift from L1 to L2, as price ratio is changing, their what? Price consumption curve will also change. On the other hand, what do we have here? In case of perfect complements, right? The income consumption curve is also a line through the corners of the L-shaped indifference curves. See the figure below. So this is again left shoe and right shoe we are measuring. L1 and L2, those are what? Now look, this slope is equal to this slope. So here price ratio does not change. This entire budget line shift up and to the right. So it's a parallel shift. Slope does not change, which means that here that slope not changing, price ratio, price of left shoe and price of right shoe is not changing. Only what? Only income is increasing, right? And that puts the budget line out from L1 to L2. Here, this is one equilibrium, this is another equilibrium. So now we can say that as his income increases, his income consumption curve will follow that line. See that? Follow that line. So that all those combinations are then his income consumption curve. Now,